Hello friends, myself Professor Rajendra Baburao Gharse. I have completed BE in Electrical Engineering from Government College of Engineering Karad and MTech from Indian Institute of Science Bangalore. I am the GATE All India 7th ranker. I am having total teaching experience of more than 9 years. Currently I am working as an Head of Electrical Engineering Department at NB Navle Sinhagad College of Engineering, Solapur. Right? In my last video we have discussed about the operation of single phase half bridge inverter for purely resistive load. Today we are going to discuss the numerical based on that theory. Okay, so suppose we are having a question like a single phase half bridge inverter has a resistive load of 10 ohm and the DC input voltage is 96 volt, right? So we're having a single phase half bridge inverter. Its input voltage, that is EDC, is equal to 96 volt, and it is given that a load is resistive and its value is 10 ohm. So R is equal to 10 ohm. Now next our task is to find the RMS value of output voltage. RMS value of output voltage means V0 RMS. Second bit, RMS value of fundamental component of output voltage, right? RMS value of fundamental component of output voltage means V01 RMS. RMS value of first 5 harmonics of output voltage. Be careful, the fundamental is not the harmonic, right? Apart from the fundamental, whatever the components those are present in the output voltage, those are the harmonics, right? So after the fundamental we are having the third, fifth, seventh, ninth and 11th harmonics. So for the third bit we need to find V03 RMS, V05 RMS, V09 RMS, V011 RMS, V07 RMS, right? Next, fundamental power consumed by the load. Fourth bit, fundamental power consumed by the load. So here we need to find the power consumed by the load due to the fundamental component, of the voltage as well as a current. So here we need to find P01, right? And last one, RMS power consumed by the load, means the total power consumed by the load, that we need to find. Means here we need to find the, for the fifth bit we need to find the P0, right? So next, so this is about the question. Next, so we are having the expression for the output voltage V0, right? This V0, it indicates the instantaneous value of the output voltage, right? It is equal to summation, yes, over n is equal to 1 3 5 up to the infinity. We already discussed it in my last video. Okay, so n is equal to fundamental component, n is equal to 1 means fundamental component, n is equal to 3 third harmonic, n is equal to 5 fifth harmonic, n is equal to 7 seventh harmonic, and till infinity. So it is like 1 3 5 7 9 11 13 15 17 etc. till infinity. Yes, we are having 2 EDC by n pi, 2 EDC by n pi. Here we are having the n, this n value will be same as that of this n value, right, into sine of n omega t. So can we say that we write it as V0 is equal to, as this is a summation is nothing but the addition. So for n is equal to 1, can we write it as, for n is equal to 1, yes, we can write it as 2 EDC by 1 pi, 2 EDC by 1 pi means 2 EDC by pi into sine of omega t. So here V0 is equal to 2 EDC by pi into sine of omega t. This is a output voltage instantaneous value due to fundamental component, Similarly, for n is equal to 3, we will be having 2 EDC by 3 pi into sine of 3 omega t. This is a output voltage due to third harmonic component. Similarly, for n is equal to 5, it is 2 EDC by 5 pi into sine of 5 omega t. So this is the output voltage for due to the fifth harmonic component. Similarly, n is equal to 7, 2 EDC by 7 pi into sine of 7 omega t. So here if you check the output voltages for fundamental, third, fifth and the seventh harmonic, right? So here, as this is, all these are sinusoidal terms, right? So here can we say that 2 EDC by pi is a peak value of the output voltage due to fundamental component? Yes. Similarly, 2 EDC by 3 pi is a peak value of output voltage due to third harmonic component. 2 EDC by 5 pi is the peak value of the output voltage due to fifth harmonic component, and 2 EDC by 7 pi it is the peak value of output voltage due to seventh harmonic component, right? So can we say that yes, peak value of the fundamental component output voltage and peak value of the output voltage due to third harmonic component, yes, it is 2 EDC by pi, it is 2 EDC by 3 pi. Yes, so this output voltage or the peak value of the third harmonic component output voltage is 1/3 of fundamental, is 1/3 of fundamental. Similarly, fifth harmonic output voltage peak value is 1/5 of the fundamental. Similarly, seventh harmonic 1/7 of the fundamental, right? But what about the means, can we say that as the number, as the order of the harmonic goes on increasing, its peak output voltage goes on decreasing, if the peak value decreases, so what about the RMS value? Definitely the RMS value will decrease. Next, what about the frequency of the fundamental component? It is a omega, right? What about the frequency of the third harmonic component? It is a 3 omega. What about the frequency of the fifth harmonic? It is a 5 omega. And what about the seventh harmonic? It is a 7 omega. So can we say that as the order of the harmonic goes on increasing, its frequency also goes on increasing, means the frequency of the output voltage of the harmonic increases as the order of the harmonic increases, right? But its output voltage goes on decreasing, right? Next, so it is given that EDC is equal to 96 volt. EDC is equal to 96 volt. So for the first bit they have asked for the RMS value of the output voltage, that is V0 RMS. As we know, V0 RMS we already derived the expression for V0 RMS. Yes, it is equal to EDC by 2, so it is 96 by 2, that is a 48 volt. Next, they have asked for the RMS value of the output voltage due to the fundamental component, that is a V01 RMS. V01 RMS we need to find, right? So what is the V01 RMS? V01 RMS is nothing but the V01 peak divided by root 2. But how to find V01 peak? That is a peak value of the output voltage due to fundamental component. Yes, we are having V01 means this value. V01 means 2 EDC by pi into sine of omega t, V01. So what about the V01 peak? V01 peak is 2 EDC by pi. So it is V01 peak is 2 EDC by pi. So what about the V01 RMS? 2 EDC by pi divided by root 2. So further can we write it as 2 EDC by pi divided by root 2 means root 2 EDC by pi. So after putting the values, we will be getting V01 RMS is equal to 43.21 volt. Yes, are you getting the point? So this is the RMS value of the output voltage due to the fundamental component. Next, third bit, they have asked for the RMS values of the output voltages due to first 5 harmonics, right? As I said, the fundamental is a component, it is not a harmonic. So n is equal to 1 is a component, right? So fundamental component. Next, after that, after the n is equal to 1, next is n is equal to 3, because n is equal to, that is a second harmonic is a even harmonic, and whether the even harmonics are present in the output voltage? No. So that's why here n is equal to 2 is not there, right? So directly we need to take n is equal to 3. N is equal to 3 means we need to find the V03 RMS, right? So V03 we are having, it is 2 EDC by 3 pi into sine of 3 omega t, right? So it is a sinusoidal. Yes. So what about its peak value? Peak value is 2 EDC by 3 pi, 2 EDC by 3 pi. So what about the RMS value? As we know, for any sinusoidal waveform, RMS value is peak divided by root 2. So it is 2 EDC by 3 pi divided by root 2. So further can we write it as root 2 EDC by 3 pi, right? But what is the V01 RMS? It is a root 2 EDC by pi. V01 RMS is root 2 EDC by pi. Here we are having V01 RMS. Yes, it is root 2 EDC by pi, right? So from this can we write V03 RMS is equal to 1 by 3 into V01 RMS? Yes, so therefore V03 RMS is equal to, after putting the values we will be getting 14.405 volt, right? Next, similarly, can we write for V05 RMS? Yes, V05 RMS, it will be V05 peak divided by root 2, right? So what will the V05 peak for the V05? Yes, for the V05, what is the output? It is a 2 EDC by 5 pi into sine of 5 omega t. So what about this 2 EDC by 5 pi? It indicates the peak value. So 2 EDC by 5 pi divided by root 2 means it is RMS value, right? 2 EDC by 5 pi divided by root 2, it will be your RMS value. So can we write it as 1 by 5 into V01 RMS, 1 by 5 into V01 RMS, right? So V05. Next, similarly, V7th harmonic, it is 1 by 7, 9th harmonic, it is 1 by 9, and 11th harmonic, it is 1 by 11 into V01 RMS, right? So they have asked for the first 5 harmonics. So first 5 harmonics are, yes, 3rd, after that 5th, 7th, 9th and 11th, right? Next, 4th bit. In the 4th bit, they have asked for the fundamental power consumed by the load. Be careful. Here it is, they have asked for the fundamental power, not the total power. Fundamental power means the power consumed by the load due to the fundamental voltage, right? So as we know, in any resistive load, what is the power? Yes, it is a V square divided by R, right? So instead of V, we need to consider V01 RMS square, right? Because V square means it was a V RMS square actually, right? So it is V01 RMS square divided by R. What is the V01 RMS? V0 RMS is RMS value of the output voltage due to fundamental component. We already calculated it, right? So put the value, you will be getting the value of P01, that is a fundamental power consumed, P01, right? Next, last bit, they ask for the RMS power consumed by the load, right? RMS power consumed by the load means the total power consumed by the load. So for finding the total power consumed by the load, we need to consider V0 RMS. So power consumed by the RMS power consumed by the load, yes, it is a P0 or P0 RMS, it is a V0 RMS square upon R, right? We know V0 RMS, it is EDC by 2, so it is a, yes, 48 square divided by R is 10, so you will be getting the answer 230.4. So this is about the numerical based on the single phase half bridge inverter with purely resistive load. Okay, thank you. In my next video, we will be discussing about the operation of single phase half bridge inverter with purely resistive load, with RL load. Thank you.